The goal of Indian space program is to harness space technology for applications in the areas of communication, broadcasting, meteorology, disaster warning, search and rescue operations, navigation and remote sensing. Operational systems have been realized in all the above areas during the past 2 decades. In this chapter, we will be discussing about various satellites launched by India as IRS missions are classified based on their applications as Land and Water Resource Observation Series, Ocean and Atmospheric Observation Series, Cartographic Satellite Series, Microwave Remote Sensing Series, Space Science Series, Micro and Nano Satellites, University Satellites. Indian Remote Sensing System. Remote sensing is an important part of the Indian space program and the Department of Science. Government of India is a nodal agency for realizing of the National Natural Resource Management System, the National Resource Information System and the Integrated Mission for Sustainable Development. Besides, several other national level application projects like crop, acreage and production estimation, National Drinking Water Mission and wasteland mapping, etc. in close collaboration with our user agencies. Operational satellites have been indigenously built and launched which cater to the land and ocean applications. Indian remote sensing program has come a long way since the first experiment conducted by aerial surveys to monitor coconut wilt disease in the early 70s. Noting the immense potential benefits of the remote sensing in the areas of resource survey, inventory and management, the Indian Space Research Organization has embarked upon the development of this technology in a major way through the use of orbiting satellites. Indian Space Research Organization ISRO planned a long-term satellite remote sensing program in 70s and started relating activities like conducting field and aerial surveys, design of various types of sensors for aircraft surveys and development of number of applications or utilization approaches. These were followed by planning, designing, fabrication of experimental satellite remote sensing missions, Bhaskara 1 and 2, etc. These missions gave experience in developing the remote sensing satellites, setting up of ground-based data reception and processing systems, experience in overall mission management, etc. The launch of IRS-1A satellite on 17th March 1988 into the orbit is the start of operational remote sensing era of IRS program. The IRS satellite are providing imagery data for many national important projects and applications. Some of the remote sensing applications being catered are multiple crop production estimates of area estimates, crop health estimate, land and water resource optimization, urban planning and management, infrastructure planning, coastal zone studies and regulation, fishing, chlorophyll, phytoplankton, etc., mapping and inventory of forest, wastelands, land use, lunar and stellar observation missions, land and water resource observation satellites. This series of satellites cater the requirement of agriculture, forestry, land use, land cover, soil, geology, terrain, water resources, disaster management like flood, forest fire, drought, landslide, etc. Satellite launched of these applications are IRS-1A, IRS-1B, IRS-1C, IRS-1D, IRS-P6 that is ResourceSat-1, ResourceSat-2 or 2A and IMS-1A. Following the IRS satellite are operational and providing data for land and water resource application. ResourceSat-2 satellite with improved performance having 3 payload namely LIS-4 with 5.8 meters resolution and 70 km swath in 3 bands, LIS-3 with 23.5 meters resolution and 140 km swath, and AFIS with 56 meters resolution and 740 km swath was launched on 20th April 2011 and successfully operationalized, and it is providing data for above said applications. ResourceSat-2A, that is the RS-2A mission, was launched on 7th December 2016 to provide a continuity of operational services of Office, LIS-3 and LIS-4 payloads. Primarily, the spacecraft configuration of RS-2A is similar to RS-2, with few incremental changes in some of the systems to take care of in-orbit observation of RS-2 and improve the overall mission operation management. A new payload, solid-state C-band transponder, is added to aid the calibration of C-band radars in SDSC SAR. Following satellites are also planned in the future to provide continuity services with improved features, ResourceSat 3 series and ResourceSat 3S series. Ocean and Atmospheric Observation Series. Under Ocean and Atmospheric Observation Series, satellites were launched to meet the needs of potential fishing zone forecasting, sea state forecasting and coastal zone studies. It also provides inputs for weather forecasting and climatic studies. Satellites launched for these applications are OceanSat 1, OceanSat 2, Megatrophics, SARAL, SCARSAT 1. Following satellites are operational and providing data for ocean and atmospheric observation applications. OceanSat 2. Satellite with ocean color monitoring payload with 360 meter spatial resolution and 1420 kilometers swath and cube band pencil beam scatterometer and radio occultation for sounding of atmosphere was launched on 23rd September 2009, was successfully operationalized for providing data for applications. Megatrophics. Under Ocean and Atmospheric Observation Series to study the convective systems that influence the tropical weather and climate, the Megatrophics mission was launched on 12th October 2011. The Megatrophics spacecraft carries 4 payloads, namely Madras, a microwave imager to study the precipitation and cloud properties, Sapphire, a microwave sounding for the retrieval of water vapor vertical profiles, Scarab, a radiometer for measurement of outgoing radioactivity fluxes at the top of the atmosphere, and ROSA, radio occultation for sounding of atmosphere to provide the vertical profiling of temperature. The Megatrophics mission provides sampling of water and energy budget of the tropical convective systems in the intertropical band, SARAL. Another international cooperative mission in the area of Ocean and Atmospheric Series is SARAL, satellites for Argos and Altica missions to provide data for marine meteorology and sea state forecasting, operational oceanograph seasonal forecasting and climate monitoring, and to provide data for ocean, earth system and climate research. The SARAL spacecraft carries 2 payloads, namely Altica, a car band altimeter, and Argos, a data collection system from Argos platform. The payloads provided by CNES France and the mainframe, and the assembly integration and testing and launching is by ISRO. SCARSAT 1. SCARSAT 1 is a continuity mission for scatometer payload SCAT-1 on board OceanSat 2 spacecraft. This mission is providing continuity of weather forecasting services to the user communities, as SCAT-1 payload was declared non-operational. The data from this payload was being used by many national and international users. Hence, demand for the new satellite with only scatterometer has come up. The SCARSAT-1 carries Q-band scatterometer named as SCARSAT 2 payload. OceanSat 2 scatterometer was SCAT-1, similar to the one flown on board with OceanSat 2 but with enhanced features. Scatterometer is an instrument working on the principle of black scattering energy and is used to measure the wind velocity over the ocean. Following satellites are being planned in the future to provide continuity services with improved features: OceanSat 3 series and SCARSAT series. Cartographic satellite series. In order to meet a large scale and thematic maps for urban and rural infrastructure development and management, and to provide national digital elevation model for cadastral overlay, these satellites were launched. They cater cartographic application, coastal features mapping, coral reef mapping, and for mineral studies. The features of these satellites are TRESS with less than 1 meter resolution pan, Cartosat-1 with 2.5 meters resolution pan and 30 km swath with along track stereo imaging capabilities. Cartosat-2, 2A, 2B with 0.8 meter resolution pan with 9.6 km swath. In order to meet the increasing demand for large scale mapping and other cartographic applications for terrestrial level and for urban and rural infrastructure development and management, Cartosat-2A and Cartosat-2B with 0.8 meter resolution pan with 9.6 km swath were launched for above applications. Cartosat-2 series satellites are high resolution remote sensing satellite configured with panchromatic camera and a 4-band multispectral camera operated in time delay integration mode. It provides scene specific imageries of 0.64 meter spatial resolution in panchromatic camera and better than 2 meter in multispectral camera with a swath of 10 kilometers. Satellites launched for these applications are TRESS, Cartosat-1, Cartosat-2, 2A, 2B, Cartosat-2S. The satellites are operational and providing data for cartographic application. Satellites are planned in future to provide continuity services with improved features such as Cartosat-2S, ResourceSat-3S series, Cartosat-3 series. Microwave remote sensing satellite series. In order to provide data during the cloud cover seasons over the tropical regions for many applications like agriculture and damage assessment during floods or for mitigation effects, microwave remote sensing satellites are planned. The ReSat-1 with C-band synthetic aperture radar (SAR) is an advanced stage of assembly, integration and testing. The SAR payload with C-band TR models have undergone extensive testing and evaluation at SAC Ahmedabad and delivered for integration with the spacecraft. The mainframe systems are also in the advanced stage of integration. The spacecraft can operate in different modes of operation and provides various resolution imageries like high resolution spotlight mode provides 1 to 2 meters resolution with 10 kilometers into 10 kilometers spot scenes. Fine resolution strip mode provides 3 to 9 meters resolution with 30 into 30 kilometers scene. Fine resolution ship mode provides 6 to 9 meters resolution with 30 kilometers swath. Medium resolution scan SAR mode with 25 meters resolution with a swath of 120 kilometers. The ReSat-1 is providing all weather day and night images for applications in the areas of agriculture for identification, detection and classification for arcage estimation, forest type plantation and accurate biomass estimation, flood mapping to provide accurate flood inundation zone for early relief measures, soil moisture and hydrology including snow cover and snow wetness etc. Satellites are also planned in the future to provide continuity services with improved features. ReSat-1A, ReSat-2A, NISAR. Space Science and Planetary Series. The study of lunar and stellar sources provide better understanding about the universe and planet creation etc. There are a number of series of satellites such as IRS-P3, Indian X-ray Astronomy Experiment, payload on IRS-P3 satellite launched in 1996. Observational study of many bright X-ray binary star systems including X-ray pulsars and stellar mass black hole candidates have been carried out. Studies of mass accretion around neutron stars and black hole binaries were some of the major outcomes from this experiment. Chandrayaan-1. The launch of Chandrayaan-1 has demonstrated the technological capabilities of reaching the outer planets and has confirmed the scientific findings of the previous international missions like the presence of water molecules and other precious elements on the surface of the moon. The significant scientific findings have provided impetus to further space research activities in the country and has created a special awareness and enthusiasm among the younger generation. Mars Orbiter Mission. Mars Orbiter Mission is ISRO's first interplanetary mission with an orbiter craft designed to orbit Mars in an elliptical orbit of 366 kilometers into 80,000 kilometers. Mars orbit mission can be termed as a challenging technological mission considering the critical mission operation and stringent requirements on propulsion, communication and other bus systems of the spacecraft. The primary driving technological objective of the mission is to design and realize a spacecraft with the capability to perform the earthbound maneuver, Martian transfer trajectory and Mars orbit insertion phase and the related deep space mission planning and communication management with a distance varying from nearly 60 billion kilometers to 360 billion kilometers. Given that the round trip light time to Earth and Mars can vary anywhere between 6 to 45 minutes, it could be impractical to micromanage the mission from Earth. Therefore, autonomous fault detection, isolation and recognition becomes vital for mission. Astrosat. The multi-wavelength astronomical observatory, the Astrosat, is an IRS class satellite with a mass of about 1550 kgs and power generation capacity of about 1600 watts. It is launched from Satish Dhawan Space Center, Sriharikota on 28 September 2015 by PSLV C-30 to a 650 kilometers near equatorial orbit with an inclination of about 6 degrees. The Astrosat carries on board a total of 6 experiments, that is ultraviolet imaging telescope, soft X-ray telescope, large area X-ray proportional counter, cadmium zinc telluride imager, scanning sky monitor and charged particle monitor. Satellites are also planned in the future for space exploration are Chandrayaan-2, Aditya L1, Mars Orbit Mission 2, Venus Exploration. Micro and nano satellite series. IMS-1, with the advances in miniaturization and the advances in high performance devices and techniques, it has become feasible to realize the functions of bigger satellites into micro and nano satellites. The ISRO's first mini satellite IMS-1 with 36 meters resolution MX with 141 kilometers swath and 505 meters resolution hyperspectral imager with 64 bands has been realized within 85 kgs and was launched successfully during April 2008. YouthSat. This satellite is second in the series carrying 3 payload, namely Solrad, Livhisi and Rabbit. It was launched into space on 20th April 2011 by PSLV 16 along with ResourceSat-2. The Solrad payload monitors the solar activities through hard X-ray gamma rays and particular mostly electrons and protons. The effect of the solar activities on the atmosphere is studied by the Rabbit. The effect on the thermosphere, which coexists with the ionosphere, is monitored by Livhisi. Microsat. Microsatellites or microsat are small satellites with small volume, low power requirement and weighing 100 kgs. Microsat is an advanced optical remote sensing satellite for providing spot imageries with high spatial resolution in panchromatic band and night imaging using IR payloads. Payload requirements are met by choosing sun synchronous near earth orbit of 300 kilometers into 350 kilometers with 10:30 am descending node local time. The satellite is designed with heritage from IMS-1 and YouthSat. This is a technology demonstrator and the forerunner for future satellite of this series. The satellite bus is a modular in design and can be fabricated and tested independently of payload. The interest and enthusiasm created by the launch of many nano satellites in a single launch by the PSLV induced many student communities from colleges, universities and Indian Institute of Technologies to involve in the development of many micro and nano satellites for various applications. Indian Nano Satellite INS is a versatile and modular nano satellite bus system envisioned for future science and experimental payloads. With the capability to carry up to 3 kgs of payload system is developed as a co-passenger satellite to accompany bigger satellites on PSLV launch vehicles. Its primary objectives include providing a standard satellite bus for launch on demand service and providing opportunity to carry innovative payloads. INS-1A and INS-1B nano satellites offer a compelling alternative to large space projects with a capability to support commercial, governmental, academic application in a responsive and cost effective manner. Also, the nano satellites have lot of potential in future and give rise to lot of new developments in various technologies and are needed from strategic point of view in the near future. In the view of this, ISRO has developed and launched the first ISRO nano satellites, namely INS-1A and INS-1B on 15th February 2017. INS-1C, Indian Nano Satellite 1C, is the third satellite in the Indian Nano Satellite series. INS-1C carries miniature multispectral technology demonstration payload from Space Applications Center. Data sent by this payload can be utilized for topographical mapping, vegetation monitoring, aerosol scattering studies and cloud studies. University satellites. ANUSAT. ANUSAT, Anna University Satellite, is the first satellite built by an Indian university under the overall guidance of ISRO and will demonstrate the technologies related to message, store and forward operations. The StudSat, the first nano satellite conceived and designed by 7 engineering colleges of Karnataka and Andhra Pradesh, was successfully launched during July 2010. StudSat, weighing less than 1 kg, has a primary objective of promoting space technology in educational institutions and encourage research and development in miniaturization of satellites, establishing a communication link between the satellite and the ground station, capturing the image of the earth with a resolution of 90 meters and transmitting the payload and telemetry data to the earth station. JUGNU. JUGNU from IIT Kanpur is a nano satellite. JUGNU, weighing 3 kgs, is designed and developed by Indian Institute of Technology, Kanpur, under the guidance of ISRO. The satellite is intended to provide the indigenously developed camera system for imaging the earth in the near infrared region and test image processing algorithms, evaluate GPS receiver for its use in satellite navigation, test indigenously developed MEMS based inertial measurements units in space. SRM-SAT. SRM-SAT were successfully launched on 12th October 2011. The nano satellite SRM-SAT, weighing 10.9 kg, is developed by the students and faculty of SRM University, attempts to address the problems of global warming and pollution levels in the atmosphere by monitoring carbon dioxide and water vapor. The satellite uses a grating spectrometer which will observe absorption spectrum over a range of 900 nanometers to 1700 nanometers infrared range. Satyabhama Sat and Swayam were successfully launched on 22nd June 2016. Pratham and PSAT were launched successfully on 26th September 2016 and NIU Sat was launched successfully on 23rd June 2017. Since 1975, India has been successfully launching a varied range of satellites. Indian Space Research Organization, a state-run space agency of India, is responsible for designing, building, launching and operating these satellites. From India's first satellite Aryabhatta launched in 1975 to EOS-04 in 2022, India's space journey has been spanned 47 years and over 120 satellites. The IRS program, started in IRS data, is used for the observation and management of the country's natural resource application in agriculture, hydrology, geology, drought and flood monitoring, snow studies and land use, etc. To utilize the Earth series, a continuous supply of synoptic, repetitive, multispectral data of the Earth's land surface is obtained. The initial program of the Earth's surface imaging was extended by the addition of sensor for complementary environmental applications.